Assalamu alaikum, I'm Video1. I'll be explaining the first lesson in the part of organic chemistry, which is chapter 8, functional groups, part 1. At the end of this lesson, you will be able to recognize the functional groups of alcohols, aldehyde, ketones, carboxylic acids, and you will be able to classify isomers as functional, skeletal, and positional. First of all, let's do an introduction, which is a kind of recall about organic chemistry or organic compounds. What is an organic compound? Organic compounds are compounds that contain the element carbon. So this is an example of an organic compound. As we can see, it is a must contain carbon atom in it. This doesn't mean that all compounds containing carbon are necessarily organic. For example, you know that CO2, for example, that is carbon dioxide or carbon monoxide, or H2CO3, CaCO3 containing carbonates. These are compounds containing the element carbon, as you can see here, but they are not organic. But regarding organic compounds, as we said, it is a must to contain carbon element, as we said in previous classes. What about functional group, which is the title of our lesson? By definition, the functional group is an atom or group of atoms within an organic molecule that gives the molecule its structure, its characteristics, story property, and definitely its chemical properties. The functional group determines the chemical reactivity of organic compound. According to their functional groups, the organic compounds are classified in families. You know that a family member or the family members share common characteristics. This is why when we have the functional group here, we will belong to the same family. Each family contains molecules having the same functional group. This is a table that summarizes the organic compound you've already known and the ones that we have to study this year also. About the general formula, first of all organic study starts by alkanes. Alkanes have what we call the general formula, that is CnH2n plus 2. Alkanes are considered to have no functional group, and their family name is called alkane. In chemistry, definitely the word alkane changed, for example, methane, ethane. This is what we have to see in previous chapters. We have also another family, which is the family of alkene. Alkene have a general formula that is CnH2n. What is the functional group of alkene? It means what is the part of the molecule that determines the characteristics or the properties of alkene. It is in reality the double bond between two carbon atoms. And definitely their name are alkenes. This ene changes according to the this enes characterizes their name. Now the third family is that of alkyne, having a general formula of CnH2n minus 2, and the functional group, it is a triple covalent bond between two carbon atoms. Now, about alcohol. Actually, alcohol, we have many general formulas, or the general formulas can be represented in different way. We have the first one, CnH2n plus 1 OH, or we can add this hydrogen to those hydrogen and it becomes CnH2n plus 2O, or simply we can represent it by ROH. What is R? In organic chemistry, R represents what we call an alkyl group. An alkyl group, it means something containing carbon and hydrogen without any other functional group. Now, the functional group of alcohol, as you know from last year, it is a single covalent bond OH, which is called the hydroxyl group. What about ether? Ether is new. You didn't see it last year, neither the years before. Its general formula is CnH2n plus 2. As you can notice, the ether have the same general formula as alcohol, but here it can be written in a different way, or ROR, and R, as we said, it is the alkyl group. Okay, so the general formula, the functional group is O double or single covalent bond from the two sides. Actually, ethers are not required this year concerning their general formula and their functional group, but we have to see for which reason did we explain it. Aldehyde is a family of organic compounds studied last year. Its general formula is CnH2nO, or it can be represented by C double bond O, single covalent bond H, and here is R, which is an alkyl group. Now for aldehyde, R can be H. It means R here can be replaced by H or by an alkyl group. This functional group is written in that way. It's called the carbonyl group. And the name of aldehyde ends by al, as we said. For nomenclature, we will see it in the previous or in the coming lessons. For ketone, is another family of organic compound. As you can see, the general formula here, it is the same as that of the aldehyde, but this one changes. Why? Because we don't have the right to write H here. If R or R prime here are replaced by H, it turns to be an aldehyde. It would not be a ketone anymore. So R and R prime can be alkyl group. The functional group is called carbonyl as that of the aldehyde, with the difference that here we have H, here we don't have H. And their name ends by on. Now the carboxylic acid, they have a general formula CnH2nO2. Actually in this here you have just carboxylic acid and another family containing 2 oxygen. So the general formula is RC double bond OOH. R here can be H or an alkyl group, and the functional group that is here for carboxylic acid, it is C double covalent bond OH, is the carboxyl group, and their name, they are called alkanoic acid. What about the general formula? The general formula of a family can be written as in the previous slides, either in terms of R or in terms of N. An example, alcohol's general formula is either written ROH in terms of R or CnH2n plus 2O, in terms of N. Actually, ROH is more general than this one, since it fits all alcohols. But CnH2n plus O fits alcohols having saturated, it means all bonds are single covalent bond, and non-cyclic, it means linear carbon chain. In this here, for all families, you can use the general formulas in terms of N, since you are responsible only for molecules having non-cyclic and saturated carbon chains. How to identify alcohols and ethers? We said in the previous slide that alcohols and ethers have the same general formula, which is CnH2n plus 2O. Why are they different? Do they belong to different families? Let's consider this example. This general formula C4H10O satisfies the general formula CnH2n plus 2O. So an organic compound having a molecular formula of C4H10O can be either an alcohol or ether. Actually, the structural formula, it means the formula that shows how the carbons and hydrogen and oxygen are bounded to each other, allows us to identify its family. Suppose the formula is the following. As you can see here, what do we have here? We have OH, that is hydroxyl group. So hydroxyl group is the functional group of what? Of alcohol. So this compound is an alcohol. While if the structural formula is in that form, as you can see here, the functional group is inserted here, is 1 oxygen, so it would be an ether. So actually the structural formula will allow us to identify the family between alcohols and ethers. Here we have directly to go to what do we call in chemistry structural isomerism, or simply isomerism. What is isomerism? Isomers are organic compounds that have the same molecular formula but different structural formulas. What are the types of structural isomers? In this lesson, we have to study that we have 3 types of structural isomers, which are, this is to be memorized, functional isomers, we have skeletal isomers, and we have positional isomers. What does each term means? Let's see. For the functional isomers, as its name indicates, functional. So functional isomers are the compounds that have the same molecular formula but different functional groups. Definitely, when we have 2 isomers which are functional, they belong to different families of organic compounds. They have definitely chemical properties that are different, since the functional group determines the family and thus the chemical properties, and they have different physical properties. Let's consider an example. Look at this. It's a propanol. What about its functional group? As you can see, it is C double bond O and H. Here it's a propanone. It is simply C double bond O. So here these 2 compounds have the different functional group. So definitely they would be what? Functional isomers. Let's consider another example. Look at this compound. Its functional group is the carboxylic group because it's a carboxylic acid. And here the functional group is C double bond O here instead of OH, because H here is replaced by CH3. So these two compounds have different functional groups. So definitely they are functional isomers. Now, what about the skeletal isomers? Here also, as its name indicates, skeletal, it means the skeleton. What is skeletal? What are skeletal isomers? They are compounds that have the same molecular formula, definitely, but different arrangement of the carbon skeleton. It means they have different carbon chain. They have definitely the same functional group, so they belong to the same family. Definitely they will have similar chemical properties since they have the same functional group and they have slightly different physical properties. Let's consider an example about skeletal isomers. Here it's a note that these two isomers, the one that has more branches, it will have the lower boiling point. Look at this. What is the functional group? Here it is OH and here it is also OH. So since they have the same functional group, definitely they are not functional isomers. Now let's check the carbon chain they have. As you can see here, we have 4 linear carbon chains, while here 3 are linear and 1 is branched. So the skeletal or the carbon chain is different. So these two isomers are skeletal isomers since they have different skeletons or different carbon chain. The third type of isomers is the positional isomers. What does that mean? Positional isomers are the compounds that have the same main chain, it means the same skeleton, but different position of the same functional group. So the carbon skeleton is the same. They belong to the same family, definitely, since they have the same functional group. Since they are of the same family, they will have similar chemical properties and definitely slightly different physical properties. Let's consider this example. Look at this molecule and at this one. As you notice, the same functional group they have both, which is OH. Okay, so definitely they are not functional isomers. Let's check their skeleton. Look, here we have a chain made up of 4 carbon chains that are linear and here the same, so they have the same chain. So they have the same functional group, they have the same skeleton, so the single difference is at the position of the functional group, where OH here is attached to carbon number 1, while here the OH is attached to carbon number 2, and this is why they are said to be positional isomers. Now this concept map will allow you to distinguish between them. If you have two isomers, first of all, what you have to check? You have to check if they have different functional groups or not. If they have different functional groups, automatically they will be functional group, and this is how to proceed. Second, if they have the same functional group, what do we have to check? We have to check whether they have different skeleton or not. So if they have different skeleton, automatically we will say that they are skeletal isomers. But if they have the same skeleton, we will not have any other possibility of being positional. I would ask you to memorize the following hint. FSP. What does this? F for functional, S for skeleton, and P for positional. So you have always to proceed in the same way. First you will look whether they are functional isomers or not. If they are functional isomers, full stop. If they are not functional isomers, it means they have different functional group, same functional group, go to check their skeleton. If they have the same carbon chain, they will be definitely positional. So memorize FSP. This will be the order that you have to follow to check the type of isomerism. And which families are functional isomers? Here you have to know that the families that are functional isomers are alcohols and ethers. As you notice, they have the same molecular formula, but as you can see, they have different functional group, so they are functional isomers. We have aldehyde and ketones, as you noticed here. We have C double bond carbon with 1 hydrogen, and here C with double oxygen, but here we have alkyl group and alkyl group, while here we have hydrogen. And finally we have acids, carboxylic acid and esters. Actually we didn't talk about esters this lesson, we will talk about later, but keep in mind that acids and esters are functional isomers. Now I will ask you to read what you have in the agenda and to copy what is required, and you have to solve these exercises as homework. Thank you. See you in the next part.